Hey World Civ, I know we weren't expecting to be doing this year, but thanks for hanging in there. Hopefully this is just a week, and hopefully this video lesson helps you understand a little bit of what we're doing today, even though it doesn't quite replace the classroom, right? So, hello, it's good to see you. I hope you are having a good week so far. Today we're going to talk about different types of maps and their uses, and we're also going to talk about map projections. Now, you should have read about this a little bit yesterday, and so hopefully it's more of a review than anything new. So, first of all, we're going to talk about different types of maps. Now, the first type of map, and probably the one that you think of when you think of a map, is the political map. A political map doesn't show any landscape features except for maybe some water, like, the oceans and the Great Lakes and things like that. Instead, these maps tell you your political boundaries, right? So all of your countries, capitals, things like that. They're usually clearly marked. Usually they've got all sorts of different bright colors on them. Obviously, the nations aren't those colors, but it's easier to tell where the boundaries are when they're separated by different colors. Political maps are mostly used for locations, states, cities, countries, things like that. The next type of map you have is a climate map, and if you would like to look at pictures, feel free to reference the reading from yesterday as I talk through these maps. Your climate map shows an area's weather and climate patterns over a long period of time. Now, keep in mind that if you're looking at a printed climate map, it's not going to show the correct climate for any given day, but it will show you the patterns. So if you're looking for climate, if you're looking for weather, or let's say you're packing for a vacation in a new place, a climate map is going to help you. Usually the map will show you things like average number of cloudy days, temperature ranges, average rainfall, snowfall, so that way you can prepare. So climate maps are the maps that they show you on the Weather Channel, things like that. Then we have physical maps. Physical maps show, as you might guess, physical features. Landforms, right? Rivers, lakes, oceans, mountains, valleys, deserts, land elevation, things like that. Usually they color code for elevation here. So it's very easy to tell where the big mountain ranges are. It's very easy to tell large stretches of flat land, things like that. So that's going to be your physical map. The next type of map is called a resource map. It's also called an economic map because resources have economic value. A resource map shows economic activities or natural resources in an area. Usually they use symbols. Sometimes they use color coding. So colors might show products that are available. Symbols might show industries. They might even use letters of the alphabet to notate different industries as well. The symbols, shapes, and colors don't mean anything on their own, and so it's really important with a resource map to look at the key to tell you what each symbol or color or letter means. The next type of map is called a population map. As the name gives away, the population map is going to show a population distribution, so where areas are heavily populated, where they're lightly populated. A population map of Florida, of course, is going to be very dark around the Orlando area because there's a lot of people here. Almost all the other maps focus on man-made things. Think about it. Even a political map shows a man-made boundary. However, population map focuses specifically on people, who lives where, how closely packed they are, things like that. And so population maps are usually very polka dotted because people tend to scatter or get dense all over the place. Now these are only some of the maps, but these are the most common. But let's jump back for a minute and let's talk about how we make maps in the first place. Now, the Earth is a sphere, right? Have you ever, and you could try it if you wanted to, have you ever taken an orange peel, ripped it off in one piece, and tried to lay it perfectly flat without ripping it at all? Well, it's not possible. Oh, sorry, I need to plug in my computer. There we go. It's not possible to do so. It's not possible to make a sphere flat. It has to get what we call distorted or messed up in one way or another. Now, in order to get a projection, I want you to imagine that the Earth is a wire sphere, and inside of it there's a light bulb. And what you do is you turn on the light bulb and you put a piece of paper, you wrap it around somehow. You could put it on top, you could wrap it in a cylinder, you could wrap it this way, and then the shadows that are made from the light passing through the globe onto the paper is going to be how we create map projections. You can get a map projection on any type of paper that can get flat and that can wrap around a sphere, but it's going to be messed up in some way. The 4 ways that a map can be distorted are shape, so the shape of land masses or lakes or bodies of water, distance, the distance between 2 points, area, so the area of a nation relative to others, and direction, so north, south, east, or west. So there are 7 projections that are important for you to know, and you should have looked through most of them yesterday. There's no map projection that's 100% accurate, but there are 7 that are very common to help figure it out. The most common is called the Mercator. The Mercator is usually a square or a rectangle. It's been around since 1569. The Mercator is a navigational tool. It's very easy to use because the lines of latitude and longitude are all directly vertical, directly horizontal. But it's got some pretty big problems. It makes Antarctica look bigger than pretty much everything else combined. So clearly it's got some area issues and things like that. But it's still pretty common. The next one is the Gall-Peters, developed by James Gall and reimagined by Arno Peters. Basically, the Gall-Peters one is going to be interesting because it does show the correct size and relative to other nations, but it distorts the area and shape a lot. You'll see when you look at the PowerPoint that in the Gall-Peters projection, things are pretty stretched out. Then you have the Mallowide. The Mallowide was developed by Carl Brandon Mallowide, and the Mallowide is oval-shaped, which is pretty similar to how we think of the Earth, right? And it is equal area, so it does accurately show size. But the shape is distorted, especially if you look near the top and the bottom of the Mallowide. You'll see that all of a sudden some land masses are curved when others are straight, so it really distorts the shape, which also distorts the directions of any given point on the map. The next one is the Robinson. The Robinson is the one that we were using to play Battleship. It was developed in 1963, and it's very common for general use. It's very visually appealing. The weird thing about the Robinson map is that it distorts all 4 of those aspects. It distorts area, shape, distance, and direction. But it distorts all of them less so. So for a lot of the other projections, they picked 2 to be accurate, 1 or 2 to be accurate, and they heavily distorted the other 2 or 3. For the Robinson, they slightly distorted all 4. And that's why it's used so commonly, because in any one specific area, it's not that messed up. Then you have the Winkel Triple, which looks kind of like you stretched out the Robinson a little bit. It's globe-shaped, it's curved, and it's designed to minimize the distortion, but again, it still enlarges the poles. It makes Greenland and Antarctica look a lot bigger than they are, and so your area is going to be a little distorted. And direction as well. The angles aren't correct on the Winkel Triple. Then you have the Good Homologine, and that one is pretty obvious to tell the disadvantages. This one really looks like someone took an orange peel, ripped it up, and tried to make it flat. It's equal area though, and so all the areas are correct, but the shape of the continents, the distance, and the direction is all distorted. And then you have the Orthograph. The Orthograph's the newest one. It was developed in 1999. It's arguably the most correct because it can fold into a globe. The areas and shapes are all fairly accurate, and so is distance. But the latitude and longitude grid is all over the place. On the other ones, you see relative lines that you can kind of follow what's going on. But on the Orthograph, the latitude and the longitude are everywhere, and so it's very distorted. And so the Orthograph is useful for some things, not for others, just like every single map projection that we talked about. So what do I want you to do now? Well, what I would like you to do is there is a worksheet chart that compares the types of maps, so political, resource, climate, things like that. And I'd like you to just in your chart put a couple things that make it unique, what makes it useful, things like that, what would you use it for. You can either print out the chart or complete it on a separate sheet of paper. Then I want you to go to the assignment called Map Projections Activity, and it'll take you to a Google Doc called Mapping Awards Activity. You're going to need to make a copy of this document in order to edit it. So once you've opened it, go up to the top, click File, go down, click Make a Copy, and then you'll be able to make a copy on your own Google Drive that you can type in and edit. Now, this one asks, it gives you 8 different award categories, like most likely to blend in, most likely to compromise, best travel companion. And I want you to go through the 7 map distortion or map projections and give each one an award. If you're not sure what a term is, look it up, like equitable or controversial, something like that. But then I want you to tell me why you chose this award for the map. Use 2 sentences. And this will help you start to differentiate what the map projections are. Remember, the 4 ways a map can get distorted are shape, size, shape, area, direction, and distance. So you can use that to help you. Now, there's 8 award categories, only 7 maps, so you will have an award category left over. There's not necessarily a right or wrong map for each awards category, but you should be able to defend your answer, okay? So those are the 2 main activities for you today. There's also going to be a second video lesson that will go over Wednesday's work a little bit for you, but that's the idea. Feel free to email me if you have any questions, but I hope after this you have a little bit deeper understanding of what different types of maps are, how we got map projections, and why they're important even though they aren't all accurate. All right, so best of luck. Feel free to please reach out if you have any questions, and I can't wait to see you soon. Bye.